In this screencast, we're going to talk about the units of measure and scientific notation. So when we talk about units, right, this is just the basic quantity of mass or volume or whatever is measured. Right? And so you're probably pretty familiar with that. It's things like miles. It can be things like a foot or inches or a yard. And this would be part of the English system. And so the English system, right, is a collection of functionally unrelated units. Okay. And this makes it difficult to convert from one thing to the other because you have to remember so much. So, for example, 1 foot equals 12 inches, which equals 0.33 yards, right? Which equals 1/5280th miles, right? And that's a real pain to remember all that. And instead, a lot of times people use the metric system. The metric system is composed of a set of units that are related to each other either like decimally is a way to say it or systematically. Okay, and these generally relate by powers of 10. And I love this map here because this shows in red the 3 countries that use the English system. So the 3 countries here that use the English system are the US, Liberia, and Myanmar. Okay, but everybody else tends to use the metric system, and that's the system that we use in science. So when we use the metric system, we have units specific to mass, length, volume, and time. All right. So sorry if it broke up there. I had to pause because of animals and children. Okay. So the metric system units, we have mass, length, volume, and time. And so mass, we've already talked about this, but just kind of as a review, is just the quantity of matter in an object. Okay? And so when we talk about, it's different than weight. When we talk about weight, this is the mass times the acceleration due to gravity. All right. Now, the standard unit for mass is the gram. And the gram is represented with a lowercase g. And you want to make sure that you watch your uppercase and your lowercase when you're doing units because sometimes uppercase can mean something different than lowercase. And mass is weighed on a balance. And so I have a picture here of an electronic balance. Now, the pound is the common English unit. And that is, for example, 1 pound is LB, 1 pound, equals 453.6 grams. Now, I'm going to require you to know the metric system units, but you're not going to be required to know these conversions. If you have to use these conversion factors in a problem, I'll give them to you, okay? But you will need to know the metric system conversions that we're going to talk about in the next slide. So then we also have length. Length is just the distance between 2 points. Okay, and that standard unit is a meter. And it's represented with an M, and that's a lowercase m. Now, the English common unit is a yard, and 1 yard, which is represented as the unit YD, equals 0.9144 meters. And again, you don't need to memorize 1 yard is 0.1944 meters. I'm putting it here so that if you need to use it to solve a problem, you'll have it easy to access. Then we also have the volume, and this is the space that's occupied by an object. And the standard unit here is liter. Which is an L. And I have noticed since just in my time on this earth that people are recognizing liters a little bit more because a lot of times our water bottles have liter marks on them. And so the quart is the common English unit, and 1 quart equals 0.9464 liters. And then time, the metric unit there is a second, which is an S. And so one of the most important things to remember is you always include a unit with your number. In lab, in class, you always need to have a unit that's included with your number. So let's go into the metric system prefixes, and you do need to know these prefixes. And so here are the metric system prefixes. And so the basic units are the units of a quantity without any metric prefix, like what we looked at. So for example, you can have something that is 27 meters, for example, right? And when we think about where that basic unit is, that basic unit falls right here. Sorry, I'm just trying to line up my line right there. Okay, so that's where that basic unit falls. If we have something that would be better, that's maybe really small, right? We would say, okay, hey, look, right now I have 32 decimeters, okay, and that's a lowercase d, which is the deci and the meter. Centa is one that you see pretty frequently. There's a centimeter, and that's, you can see that there. There's a millimeter here. This is a micro. It looks like an upside down kind of U shape with a tail. That's a Greek letter. And then nano is N. Then you have kilo and mega and then deca here. And we will go over how to convert these more in class. You need to know these prefixes and their abbreviations, as well as the conversion factors to be able to convert. And again, we will go over lots of examples of conversions in class. Now, I want us to dig around into volume just a little bit more. So, volume, if we think about, for example, this box here, okay, um, volume is what's called a derived unit. And derived units are where you do some sort of math to get there, multiplication, division, those types of things. And so volume is called a derived unit because you take the length times the width times the height to get the volume. And I want you to look up here. When we talk about 1,000 milliliters, that's the same as saying 1,000 centimeters cubed. And so what that means is 1 decimeter cubed is the same as a liter, okay? So you can see these here. One of the things to be aware of, or the things that you'll see that we'll use a lot of times the most often, is 1 centimeter cubed equals 1 milliliter. And then if you ever have a vaccine or have to give a child oral medicine, a lot of times you'll use an oral syringe. What you'll see is that 1 milliliter is 1 cc on the syringe, okay? And again, those are just volume measurements. And then, of course, okay. So again, these are derived units. Now, we're going to end this screencast with a discussion of scientific notation. Scientific notation is used to express very large or very small numbers easily, right? And with the correct number of significant figures, which we are going to get to in the next screencast, okay? Now, for example, and I'm sure you have run into scientific notation before, when we think about this, what we a lot of times see will be if you have a number like 43,000, okay, or 4,300, okay, and you want to put that into scientific notation, what you do is you take the decimal, and you're going to move it over 1, 2, 3 places. And the decimal now is going to go right here. And so what happens is you take the 4.3, and that's an imagined decimal, so we're just going to kind of ignore it right now. So we're going to make it 4.3, right, times 10 to the third, okay? And so if this was 4,300 meters, that would be 4.3 times 10 to the third meters. So if you move the decimal to the left, that's a positive number. Then if you have a number, say, for example, 0.00063, what you're going to do is you're going to move the decimal 1, 2, 3, 4 here, right? And you're moving that to the right. And you're going to put the decimal between the two non-zero numbers. And when you do that, that gives you 6.3 times 10 to the negative 4th meters. When we look at this, I want you to notice if you move the decimal to the right, you get a negative number. You are going to need to know how to put this into your calculator because we're going to work with some very big numbers and some very small numbers. And so when you enter it into your calculator, some calculators will let you enter as 6.3 times 10 raised to the negative 4th. But some will use an EE button, 6.3 EE, 10 to the negative 4th meters. If your calculations when you do this are off by a factor of 10, right? So, for example, you maybe put this in and instead of getting 0.00063, you get 0.0063. Try putting parentheses around it in your calculator, all right? So sometimes you have to enter it in your calculator with parentheses, 6.3 times 10, and you'll use a caret, like raised to the negative 4th, and that helps. Now, if you have any questions about this, I'm more than happy to help you with your calculators and show you how to put this in. Please do not get frustrated trying. I love helping students, and so just bring your calculators and I can show you how to do that.